In this lesson, we're going to look at piggyback IV solutions. So when we have two bags hanging at the same time, how can we understand the delivery of the medication? So let's look at the process that is involved here. What the authors tell us to do is step one, find the rate of flow for each piggyback. Secondly, calculate the number of piggybacks to be given. Thirdly, determine the total time and total fluid for all piggybacks. Next, step 4, determine the amount of time and volume of the fluid remaining. And finally, calculate the rate of flow for the IV between piggybacks. So we should be able to do this to find the information that we have. So the example that we're given, a patient is to receive 200 milliliters of IV fluid in 24 hours. So that is our standard medication. We are also going to order a second medication. So also ordered is a piggyback. Dissolved in 100 milliliters of fluid. To run for 30 minutes. The piggyback is to be given every 8 hours. The IV is to be kept open between piggybacks. With 5% mixture of dextrose and water. The drop factor on all tubing is 15 drops per milliliter. The first question is, what is the rate of flow for each piggyback? And what is the rate of flow for the IV between the piggybacks? So, looking at the first question, we want to find the rate of flow for each piggyback. So, what are they telling us? They're telling us we have 100 milliliters of fluid to run for 30 minutes. So, on our piggyback, 100 milliliters per 30 minutes. Now we can go ahead and we can convert that to our drop factor. So if you want to get the flow rate, we have 100 milliliters per 30 minutes. Now what's our flow rate that we use? We are told this is 15 drops per milliliter times 15 drops per milliliter, so that we wind up with a total of 50 drops per minute. In terms of our first step. Now we need our second step. We need the number of piggybacks. Well, what are we saying here? The problem says that we want to give it every 8 hours, and we are doing this for 24 hours. So the problem is starting with 24 hours. That's how long the thing is supposed to be open, and we're told 1 piggyback per 8 hours. So as hours would cancel, we wind up with 3 piggybacks. The next question says, determine the total time and total fluid volume for all the piggybacks. Well, they're telling us that each piggyback is a total of 30 minutes. So the total time, we have 3 piggybacks. Times 30 minutes per piggyback. Which will give us a total of 90 minutes for the piggybacks. And then the total volume that's involved, each piggyback is supposed to be 100 milliliters, so 3 piggybacks times 100 milliliters per piggyback would give us a total of 300 milliliters. Now, step 4 says determine the amount of time and volume of the fluid remaining. Well, we used a total of 300 milliliters for the piggyback. We were supposed to give 2,000 milliliters. So what would be remaining would be 2,000 milliliters of stuff minus 300 milliliters in the piggybacks for a total of 1,700 milliliters remaining. Now how about time? The thing was supposed to go for 24 hours. Now we need to subtract 90 minutes from 24 hours. So what would that be? Well, 24 hours is 1,440 minutes. We would need to subtract. So we have 1,440 minutes minus 90 minutes for a total of 1,350 minutes. So we have our total amount of milliliters, 1,700 milliliters, being given in the course of 1,350 minutes. We want to convert that into a drop rate. Again, 1,700 milliliters in 1,350 minutes. And the rate for our tubing is 15 drops per milliliter. So we should indeed be able to go ahead and convert this to a drop rate for our problem. So we start with 1700 milliliters in 1350 minutes times getting rid of milliliters downstairs, drops upstairs. And our conversion factor is 15 drops per 1 milliliter. And as we do the multiplication, 1700 times 15 divided by 1350 gives us a total of 18.9 drops per minute. And normally we would round that to about 19 drops per minute between piggybacks. So let's do one more of those. This time we're going to ask the patient to receive 100 milliliters, 1,000 milliliters IV every 12 hours. In addition, we're going to have a piggyback that is going to have 100 milliliters to run for 30 minutes. Piggyback is ordered Q6H. Which of course means every 6 hours. The IV is kept open between piggybacks. And the drop factor is, on all tubing, is 20 drops per milliliter. So we want to find the rate of flow for each piggyback. And the second question, what is the rate of flow for the IV between piggybacks? Okay. Question A, the rate of flow for our piggybacks. The piggyback is 100 milliliters for 30 minutes. And then we have our drop rate. Our drop rate was 20 drops per milliliter. And you'll notice milliliters cancel and we wind up with drops per minute, which is what we're interested in. So 100 times 20 divided by 30 gives us 66.7 drops per minute, which we will round up to 67 drops per minute. So that's the relatively easy part of the problem. Now we've got to go through our various process. Our next question is the number of piggybacks. So number of piggybacks is what? Well, we are keeping this IV open for 12 hours. So we're going to be infusing medication for 12 hours, but we're giving a piggyback every 6 hours. So we get one piggyback for every 6 hours. So you notice That's just going to give us a total of 2 piggybacks. So we have 2 piggybacks to work with. The next question we're going to ask for is the total time and the total fluid volume of the piggybacks. So time and volume of piggybacks. What will those be? Well, each piggyback is a total of 30 minutes. And I have 2 piggybacks. So again, 2 piggybacks times 30 minutes per piggyback. And that, of course, will give us a total of 60 minutes per time. Now, the volume is a total of 100 milliliters per piggyback. And we have a total of 2 piggybacks. So again, that will give us 200 milliliters when that cancels. So 60 minutes worth of time where the piggyback is infusing for a total of 200 milliliters. The next thing we ask ourselves to find is the total amount of time and volume of the fluid remaining. So find time and volume of fluid remaining. Well, we are supposed to infuse 1,000 milliliters of stuff. But we are going to use up 200 milliliters for the piggyback, minus 200 milliliters for the piggyback. So the total then would be 800 milliliters remaining. Now, the time that this was supposed to hang was for 12 hours. Now let's convert that to minutes. So, of course, we get 60 minutes in 1 hour. And 60 times 12 is 720 minutes. Minus, we had 60 minutes for the piggyback. So 720 minutes minus 60 would give us a total of 660 minutes remaining. So we have to deliver 800 milliliters in a total of 660 minutes. So we certainly should be able to do that. 800 milliliters in 660 minutes. We want to convert that to our drop factor, our drop rate. So our typical notion here is that the factor is 20 drops per milliliter. So we want milliliters to go downstairs, drops to go upstairs. We get 20 drops per milliliter. Milliliters cancel, and our result then is in drops per minute, which is what we're looking for the amount of time between the piggybacks. So we have 800 times 20 divided by 660, or 24.24 drops per minute. And we like to round this, so let's go ahead and say that's approximately 24 drops per minute between piggybacks. And that will conclude this lesson.